Hello everybody, I'm Paul Moran. I am a technical account manager for enterprise support within AWS. And I'm here today to talk about the deep dive in the Amazon Elastic File System. I'm here presenting with Yong Kim, the business development manager for EFS. We're a bit tight on time today, so if we can have any questions, if you've got any, just come speak to us towards the end, and we'll be able to address them as we go along. So the agenda for today, what we're going to expect from it is want you to be able to recognize why and when to use Amazon's EFS, understand the technical and security concepts around it, and learn how to leverage the performance that's baked into EFS. And finally, we're going to look at some of the economics of how EFS works and how you can utilize it. So with that in mind, I'm going to hand over to Yong, and he's going to pick up on the first section.
Thank you, Paul. Hello, folks. You can probably tell from the accent shift to where we're based. So I'm normally based out of New York City, and I'm happy to join you folks here in London today. So I thought before we got into the what's and the how's of Amazon EFS, we would start with the why. Why Amazon EFS? And a little bit of the when. And there we go. And when you look back when AWS launched storage in the cloud, for the longest time, customers have had largely two options for storage for building in AWS. Amazon in the form of object storage with S3 and Glacier, and block storage in the form of EBS for our EC2 instances. But there was one category of storage class, one type of data that was not addressed, and that was file data. And so I'm happy to say that exactly a year ago today, we launched Amazon's file offering, the Amazon Elastic File System in AWS. So happy birthday, happy first birthday to EFS. And why we think this is exciting and why we think it's important for our customers is that according to analysts, up to 80% of data in the enterprise is in file systems. It's unstructured data that's native in file systems today. So we think this has great value to our customers and developers. So now now you have the choice when you need to look at a new application or you have existing applications that utilize file systems and file system semantics. You now have your choice to leverage our file system. So that's a little of the why. When we built Amazon EFS, we built it with the following principles. We wanted it to be extremely simple and easy to use. We wanted it to be elastic. So Amazon EFS scales automatically as you add data, and it shrinks as you delete it. We wanted it to be highly scalable, both in terms of capacity as well as throughput, so you get more performance as you grow. It's highly durable. We'll talk a little bit about the specifics of EFS's design, but it is built with 11 nines of durability in mind and also highly available. It spans 3 availability zones. So simple in a few different ways. One, it's fully managed. It's what you folks would expect from a storage service at AWS. There is no hardware to have to manage. There is no software. There's no file system layer. You simply create your file system, present those mount targets to your EC2 instances, and you can start storing and accessing data. So it literally takes a few seconds to set up a file system. It supports industry standard protocols. So if you have applications that utilize NFS versions 4 and 4.1, those should be available for use right away. It supports file system semantics with very strong read after write consistency. And even the pricing is simple. It is only based on the amount of data that you use, and there's no other billing aspects. We'll talk about pricing specifically in the economics portion. So it is elastic. Again, there's no provisioning necessary. Once you create the file system, simply start adding data to it. Once you don't need it anymore, or if you don't need it anymore, remove it, and we will shrink the file system and bill you accordingly. So there's no additional capacity planning necessary, and again, there's no minimum fee. You pay only for what you use. You can grow to petabyte scale. In fact, when you first create your file system, you can see that it presents up to 8 exabytes of capacity, and we would be very welcome if you were to fill up your file systems. But they scale in performance as you grow as well. So as you add more data, the file system scales in terms of performance, which we'll talk about in a fair bit of detail here shortly. So as you add more data, the capacity and the performance scale accordingly. It also provides consistent low latencies. This is very important for a lot of applications that use file system protocols. And it's available to mount on a single EC2 instance, but it really becomes much more powerful when you see it accessed across hundreds, if not thousands, of concurrent EC2 instances. Highly durable and highly available. Every file system object in EFS is copied synchronously across 3 availability zones. That also means that data is available to be read in each and every availability zone. So you get very strong data durability and availability. And it gives you that concurrent access capability to leverage across all those EC2 instances if need be. So it is far superior in terms of traditional or a lot of on-prem network-attached storage options available today. And so we feel it's appropriate for many different applications, but certainly even production-level tier 0 applications. So if you are thinking of using our compute, our EC2, and you're thinking of storage options available to you, here's just a quick comparison of some of the characteristics between EBS, our block storage, and EFS, which is shared file system storage. So in both cases, you get consistent latency. You will still get the lowest possible latencies with EBS, but you will get low consistent latencies with EFS. In the case of EBS, you're looking at single gigabytes per second for throughput. In the case of EFS, you can achieve and sustain multiple gigabytes per second of throughput. And we'll actually review some testing that we've done there. Again, EBS stored redundantly, but within a single availability zone. EFS stored redundantly across availability zones. Okay, so even more durability. EBS is storage for an EC2 instance, whereas EFS is really meant to be shared. You can certainly mount it to a single instance, but it starts to really perform as you add more instances and access that file system more and more concurrently. And these are not mutually exclusive workloads at the bottom. These are just some of the patterns that we see our customers using the storage for. Certainly you can use EBS for big data analytics. It's not to say you can't. This is to say these are some of the use cases that we've seen across the customer base since launch. So if you were to think through, what is the right storage for a particular application, here's a kind of a thought process. If you require multiple EC2 instances, multi-attach, or multiple gigabytes per second of throughput, or that multi-AZ durability, and the automatic scaling, the grow and shrinking of storage, then EFS is probably a good option for you. there's a Windows update that needs to wait until after the presentation. So EFS is attached to multiple or to EC2 instances, but you can also attach EFS to your on-premise hosts via Direct Connect. So now your on-premise Linux systems would see the EFS file system mount points over a direct connection. And in this scenario, we see 3 primary use cases. So 3 out of these 4. Migration is if you want to move your file data into EFS. Bursting is if you want to move some of your file data into EFS. And then backup or DR is if you want to make a copy of all your file data into EFS. The one use case that we don't recommend currently is tiering. And that's when you have some of your file data accessed on-premise and some of it in EFS in the same application. We just find that the performance may not be consistent. So that's one that we wouldn't recommend at this time, but certainly those other 3 that we see. So given that it supports industry standard protocols, that it's highly scalable, it's not really surprising that we see today, in the year that it's been launched, a variety of use cases. So I'll just highlight a couple of the ones that we see. We see a lot of analytics workloads on EFS. In fact, a lot of those happen to be leveraging our Spot instances on EC2. So customers will have a large analytics requirement. They will spin up on demand a fleet of EC2 instances at bid pricing. They will run their analytics, analyze them across all the instances accessing the same file system data, and then spin them back down. And they will typically store the results somewhere out on EFS for later access. Media and entertainment, we see it in rendering and transcoding workloads. A lot of workflow management. Applications will write data into a shared repository that will then be read by other systems for other parts of the application. Database backups. So if you are servicing database administrators, it's quite easy to present a file system mount point for them to be able to take dumps of their database at their schedule, under their control, for recovery points. Container storage, supported in ECS, as well as working with Docker and Kubernetes. Clearly, home directories and user shares is another use case. And we are very common in the web serving environment. So companies like WordPress, et cetera. Where is EFS? So EFS is currently available in these regions today, these 5 regions. We have more coming soon. For you folks here, your closest region would be Ireland, so in Dublin. So that's a little of the why, and a little bit of the where, and a little bit of the when. I'd like to turn it over at this point now to Paul again, talk a little bit about the performance and security concepts.
Thank you. So, EFS, its design. It's designed to be a regional construct. It's designed to be multiple availability zones. It's designed to maintain full consistency across each of those availability zones. And it's currently, we support 1 VPC per file system, but you can have multiple file systems within that VPC. The primary resource, sorry? All right. The primary resource in EFS for storing files is the file system. As I said before, it's a regional construct. You can have 10 file systems per VPC, but that's a soft limit. You can get those soft limits increased by raising a case, that kind of thing. Default throughput is 3 gigabytes a second. Once again, that's a soft limit. We can drive considerably more throughput than that. Once again, soft limit, so raise a case, get that limit increased if you've got a requirement. It's accessible from EC2 in your VPC or through EC2 Classic via the Classic link. And it's also available, as Young said, through your Direct Connect. So what is a mount target? It allows you to access your file systems within the VPC. It's an endpoint for your NFS that lives within that VPC. And you make your mount target. It's got an IP address. It's got a DNS name. You mount against that DNS name. That mount target is available within each availability zone. And it's highly available within that availability zone itself. So how do you go about mounting EFS for your services? As we've discussed, we can use NFS version 4. NFS 4.1 is recommended. It's much more robust, better security model. So as we'll always say, the bigger fonts emphasizing that we should be using 4.1 where possible, where your workload will suit. And we support Linux kernels 4 and above. How do you go about doing it? You launch your instance, you SSH to that instance, you make your directory, you mount your EFS file system to it using your standard mount commands, and then you engage with that file system in the same way you would with any other file system on that host. As discussed, we've got the Linux kernel 4 and above. Here's the recommended mount options that are available. Just mount your file system that way and engage. Resources that are available to EFS. Tags. Tags are great across the whole of your AWS estate. They're mutable data. It's typically a key pair value. The kind of thing that you would put in it is a project name, a program of work, a customer, a service line, that kind of thing. And it helps you understand your workloads, your file systems. The mount targets themselves, as we've discussed already, you can have one or more per file system. You create them within your VPC. You have one per availability zone. And in Dublin, for example, that would be one in each of the 3 availability zones there. But they must be within the same VPC. You also have access to security groups. It's just standard security groups, the same way that you use them across the rest of your estate. You can have 5 per mount target, but the thing to remember is you've got to allow your clients to be able to access it, and you do that by opening up port 2049. On the security side of things, you've got several mechanisms that are available to you. It's kind of a 3-layer, and there is a bunch of things within each of those layers that you can do. So from the network side of things, you can control using security groups, as we've discussed, and also ACLs. You can control file and directory access using standard POSIX permissions. So that means that you can chmod, chown, all of those things within that file system, and it's interacting the way you're used to. You can also control administrative access to file systems by using the API. And you can set that control within identity and access management. And the control levels that you've got there are action levels, so what you can do, and also resource levels where you can do it. There are 3 ways of interacting with EFS: through the management console, via CLI, and also through the SDK. And it's all the standard things that you'd want to be doing. It's creating, destroying, tags, all of those kind of things. And here's the list of commands that are available to you. And there's the creates, the deletes, the describes, the modifies that you want to do in that environment. So now I would like to move on to aspects of performance around EFS. So EFS was designed for a wide range of workloads, and you've got your high throughput, parallel I/O type scenarios. You've also got your low latency and your serial I/O connections, and everything in between there. So to address that, we've considered it from the perspective of, well, distributed storage baked into the design. The file system's distributed across an unconstrained number of servers. And the benefit of doing it that way is that allows you to avoid the bottlenecks and constraints that you would in a traditional file system. And the knock-on effect of that is that enables a very high level of aggregate throughput. And a very, as we'll show you later on, a very linear scaling for that as well. The data is also distributed across availability zones for both durability and availability, but the knock-on effect for that as well is that you're also taking out bottlenecks and some of those constraints. So we've got two options in terms of how you set up your EFS file share. The first is the default one, and that's the general purpose file system. And that's for your more latency sensitive workloads, applications and the likes that have more of the fit into the general purpose category. And we find that covers off 80–90% of the different scenarios out there. That's the lowest latency type interactions that you're going to need. But the constraint around that is there's a limit of 7,000 operations a second for that setup by default. But as I said, it's best choice for most workloads. Then we've got max I/O. That allows you to process large-scale, data-heavy applications, and it's virtually unlimited in terms of how it's going to scale out and throughput. The trade-off for this one is that you've got slightly higher latencies. So, as I'll touch on a little bit later on, test, know your workload, get to understand what your requirements are, and drive that. And one of the great metrics to be able to track that is the % I/O limit. If you're bumping up the maximum end of that, start testing against max I/O. That gives you a good indication as to whether you're starting to eat away at the service in its current form, and it's time to switch modes. We also have a burst model. So that's based on the size of the file system. You start with a 2.1 terabyte burst credits. Your minimum burst throughput is 100 megabytes a second. Your baseline throughput per terabyte is 50 megs. Plus the burst throughput, when you're eating into your burst credits, you'll start to get that 150 megs for that terabyte of storage. So here's the kind of raw data by example. So you'll see, starting with a very small 10 gig file system, with burst, you'll get your 100 megs. You'll get that for 7.2 minutes through the day. But as you start to work towards your half terabyte file systems, you'll see that you get 6 hours of burst ability, with that being the 100 megs. So aggregate, you've got your 125. And once you get to a terabyte, you're getting full 12 hours of burst ability in there. And your throughput will go up as your file system size increases. So the way to think about burst model, I was thinking about an analogy, but Young's got a really good one about a coffee pot. Your burst credit is there like you take a sip of coffee, you pour your coffee, you drink your coffee. That's eating into your burst credit. You put your coffee pot back and let the coffee just keep dripping back in again. And that's very much the case for your burst credit. As when you use it, it eats away the burst credit from that 2.1 terabytes. When you are not using it, you start to get your credits replenished. Another consideration for performance is the size of your I/O. Once again, this comes back to knowing your workload. So the smaller your I/O, the smaller your throughput requirements are going to be. The bigger your I/O, you're going to drive much greater throughput. Be aware of that as you're going through the testing that you're doing. We've done a few tests ourselves, and parallelization is the way forward for using EFS. So how do you take advantage of it? Multiple threads, multiple instances, combinations of that. So you can see from this example, 160 threads driving 25,000 IOPS. And it's a near linear growth. That's not the limit of how it will scale out. That's just where we stop for this test. How do you track that and keep an eye on it and get the data that helps you to understand your workload and your test scenarios? Well, CloudWatch. We always go to CloudWatch for everything, for really understanding what your throughput's going to be. Burst credit balance is really important. If your workload it keeps bumping into your burst credit balance, keep an eye on this, set triggers and alert against it. Your permitted throughput is that 3 gigabyte second figure that I talked about before. That's the soft limit, so it's one to keep a track of though, because as you approach that limit, you want to be aware of it. So alert as you're getting closer and closer to that limit. Client connections is to help you understand how many sessions how clients are coming in to hoover up your data and interact with it. And the %IO limit one, that's the one that we keep an eye on to determine which mode we should be in. So we did a bunch of testing ourselves, 2 types of scenario. The first one was transferring media assets into EFS. And the size ranged from a few gigabytes to 100+ gigabyte type files. Data sources were S3 and EBS, as you'd expect. The other scenario was lots and lots of small files, millions of small files. Sizes ranging from 64K to 256K. And once again, S3 and EBS. We used GNU Parallel. It's a tool for executing jobs in parallel, as the name might indicate. It's similar to Xargs in that regard. And you can use it to replace loops within shell scripts. And what it'll do is it'll make sure that the output from your commands are very similar. So you get a consistent feel for your workload. And in this scenario, you look as you increase the number of threads, the time to execute is reduced dramatically. So here's an example of the command set that we used. And here are the results. So you'll see for the large file transfers, the 4.2 gigabytes a second is not the upper limit. This is just what we tested against. But the thing to call out is the consistency of those file transfers in there. And the same for the small files. 1.6 million small files transferred per minute via 300 instances. So to summarize on the performance side of things, parallelize everything. That means threads, instances, combinations of the two. Test, test, test. Nobody knows your workload, your application stack like you do. Test as much as you can. Understand what your workload is and understand your constraints, understand what your outcomes are, and then capture and analyze as much of that data as you can. Keep a close eye on things like burst credits. That'll allow you to understand when you're going to hit potential bottlenecks and understand your workload a little bit more as well. And one last thing to call out, the test that we did there with the 300 instances for the small file transfers, that worked out about $5 an hour for us. So we used Spot to drive a lot of that activity to scale out, to shrink again. So Spot's a great place to do a lot of your testing in as well. So with that, I'm going to hand over back to Young to talk through some of the economics of using EFS. Thank you.
Paul? So EFS's economics, this is a couple of different ways to look at it in relation to the other options available out there. So one of the options that we see is BYO, so build your own. These are customers that are going to use EC2 instances with EBS and then implement a file system on top of that. So if you want to run a file system in the cloud, you can certainly build your own in AWS. And when we looked at some customer experiences, what we got as pretty consistent feedback is that they were very complex and sensitive to maintain. And they're also very specialized skill sets. So when you have to make changes, it becomes a very nervous situation to see exactly what that effect might be. It's also expensive. So in addition to all of the costs associated with it, the soft costs of management, there's actual hard dollar comparisons. So as we describe the architecture of EFS, if folks were to build it on their own, this is what it would need to look like. You would have multiple EC2 instances in one AZ, duplicated across 3 AZs. You would have multiple EBS volumes to achieve the same scale and redundancy. Then you would have all of the associated interconnections, bandwidth, and traffic to make sure that every NFS client and every AZ can access data in any EC2 server and EBS volume in another AZ. So there's a lot of complexity that EFS simplifies. And of course, all those have associated costs with them. So if we look at what that could look like, these are just some example numbers, but if you were to create a 500 gigabyte file system and you left yourself 15% wiggle room for space, so 600 gigabytes, here's a cost comparison of, again, just the hardware and networking components, not the file system layer. It's roughly 3 times what EFS would be. So again, EFS, very simple pricing model. You pay for only the amount of data that you use. 33 cents per gig is the price in Ireland. Okay. So again, remember the previous diagram. This is what the EFS environment looks like. Very simplified, again, fully managed, so you folks don't have to worry about anything other than the amount of data there down in the file system. Okay. So no other billing dimensions, no upfront fees, no minimums. Those are the prices in the regions that are available today. And many more regions coming online shortly in the EU and others. When you get the slide presentations, you'll have access to these links. So here's a number of different references and resources available to you. There's a few hands-on tutorials where you can see an EFS file system from initial keyboard to live and available for storage, mounted to EC2 in a matter of 3 minutes, as well as some links to quick labs and quick starts. Yeah, I know we went through a number of things pretty quickly here, given the time. Paul and I will be available for questions here up at the front if you'd like to come and ask anything specifically. I'd like to thank you all for your time and enjoy the rest of the summit.